Stop wasting time on temperature. Gemini's new models render your old knobs useless. If you're still relying on temperature to dial in quality, you are treating a hyperscale architecture like a vintage machine. You're fighting the engine, not driving it. The core problem is trying to use stochastic search parameters, like temperature and top_p, to enforce deterministic business logic. These knobs were designed for exploration, not production fidelity. In the early models, these parameters were necessary compromises. They allowed us to wrestle unpredictability from a vast search space. But modern Gemini has compressed that search, making the compromises unnecessary. The modern approach shifts the burden of control entirely to the prompt. You are no longer whispering "be less random," you are commanding, with surgical precision, by constraining the context. Think of the system instruction not as advice, but as a non-negotiable constitutional law for the model. This is where you enforce tone, format, and constraints upfront. When you need consistency, stop hoping a high temperature setting will randomly produce the desired output. Instead, use few-shot examples and chain-of-thought prompting to encode the desired behavior. If you are using the API and need to encode this transition, your prompt must be hyper-efficient. It needs to guide the model through its own reasoning process before outputting. Let's look at the code. Here is how a naive implementation relies on temperature to fix flawed logic, leading to inconsistent production results. Now, compare that to the modern pattern, a precise prompt structure combined with minimal sampling noise. The quality comes from the instruction, not the dial. This isn't just about setting temperature to 0. It's about unlocking the model's true capacity when you treat it as a predictable, logical engine, not a creative partner. If you are scaling with Gemini and hitting quality bottlenecks, the migration path is clear. Refine your prompting constraints until they are perfect. Only then should you consider fine-tuning. Master the input, and you master the output. Stop trying to debug model behavior with generation parameters, start engineering flawless instructions.